Okie dokie. So this video is going to be on molar mass, rounding molar mass to the hundreds place. So gave you a periodic table of the elements not too long ago. Let me make sure you guys can see that. And as we evaluate each one of these squares, we've pretty much covered that this is a symbol for an element. The name of the element is here. The atomic number is the whole number below the element. The atomic number is also known as the number of protons. These would be the number of protons in the nucleus. You can also use this as a guide to atomic size. And then up here, this is called atomic mass, but we are going to start referring to this as the molar mass, the molar mass. So molar mass you find on the periodic table. It is the long decimal number on the periodic table. And if we just examine the word molar and mass we measure in grams. This is a lowercase g, but it's not in parentheses, so we're not talking state of matter. Molar is actually representing the term mole, and the abbreviation for mole is MOL, not MOLE. So molar mass is just the name itself, gives you a hint of the units. The units for molar mass, it's measured in grams per mole. Grams per mole. So those are the units for molar mass. These are the units that you will use when you report molar masses. You report molar mass for elements. This is how many grams in a mole. So how many grams in a mole. And just like when you say something like meters per second, that second, we're talking 1 second. This is grams in 1 mole. We don't write the 1, but it's grams in a mole. So molar mass is going to be grams per mole, grams in 1 mole. And to standardize this, because if we look or glance around, we can look at fluorine and we can see that there are so many decimal places in this measurement. And then we look at sulfur and there are 2 decimal places. And then we look at carbon and we're looking at 5 decimal places. We go down to lead and we see 1 decimal place. We hop around and we see multiple different precisions for this decimal number, this atomic mass. And the atomic mass is actually a weighted average of isotopes. The weighted average of isotopes. And we're not quite there to explain that yet, but since we've just covered rounding, I want to have you guys practice rounding your molar masses. As a school, we have decided that all molar masses, we're going to follow the College Board, so all molar masses are to be rounded in your head before using them to the hundreds place. So rounding in your head before using them to the hundreds place. So you will never enter this number in your calculator. You'll never enter this number in your calculator. You'll never use those numbers for any calculations. What you need to be able to do is look at the periodic table I gave you, round that number in your head, and what you get from that is what you will use and put in your calculator if needed. So you have an activity in your workbook to do this for the first 20 elements. So let me help you out for a few of those and let's show you how this is done. If we're rounding to the hundreds place or 2 decimal places, we still need to look at the third. Let me zoom in a little bit more. We're rounding. If we want to round to the hundreds, we still need to look at the third, follow the rule, and to see if that bumps up the hundreds place. And this one does. So the molar mass for hydrogen would be 1.01 grams per mole. And that is the molar mass for hydrogen, 1.01 grams per mole. If I look at lithium here, 6.941. I want the hundredths place. That 1 doesn't change it. So the molar mass for lithium is 6.94, and that's grams per mole. Beryllium has a whole bunch here. I'll never use all of those. Hopefully, this is going to get to the point you can do this in your head. 9.01 grams per mole. We go to boron. That's easy. It only gives us 2 decimal places, so we're good to go. 10.81 grams per mole. Carbon, you would use 12.01 grams per mole. Nitrogen, look at that 6. That 6 is going to cause the molar mass for nitrogen to be 14.01 grams per mole. Oxygen, when you write oxygen, hopefully in your head you realize it's just 16, but you want to show your teacher that you know you are rounding to the hundredths place. So the molar mass for oxygen is 16.00. Now when you put that in the calculator, obviously you'll just put 16 in the calculator. When you do it in your head, obviously you know that it's just 16. But if it's a test situation and you have to show your work, you're going to want to write it out for showing your work. If we look at fluorine, how does that round? Well, I want the hundredths place. That 8 bumps that 9. That 9 becomes 10, which makes this 9 become 10. So fluorine is 19.00 grams per mole. Let's see, chlorine, 35.45 grams per mole. Here's 32.06. Silicon, 28.09 grams per mole. Aluminum, 26.98. That 1 doesn't change the 8. Potassium here, 39.10 is what you would write. 39.10 is what you would write. So in your head, you do that in your head before you use it. But when are you going to need to use it? If I asked you, what is the molar mass of water? I'm asking you, how much does a mole of water weigh is what I'm asking you. What's the molar mass of water? You will take the molar mass of a single oxygen, because as we did last time, this is a single oxygen atom, and it's chemically bound to 2 hydrogen atoms. So I'm going to add that to 1, to 1. I'm just adding up my molar masses, and the molar mass of water is 18.02 grams per mole. Right? So pretty straightforward. I'm not going to do the 15.9994 and the 1.00794. I round it before I use it when calculating molar masses. This is the way Woodson has decided to standardize it. We're going with what the College Board does. That way our tests and our quizzes, and we get the same answers. Let's try a practice one. What if I wanted to do, let's say, iron 3 chloride, FeCl3? Well, that's 1 iron atom. I need to find it on the periodic table. Boom. Right here, it's 5585. Hopefully everyone can do that in their head. 55.85. And I need to add that to 3 chlorines. Chlorine is 3545. So 35.45. And I have 3 of those. So I have 3 of those. In my calculator, 35.45 times 3. And then I'm going to add that times 3, and then I will add that 55.85 for a total of 162.20. You want to show me that you know we're rounding to the hundredths place. Now, I just did this multiple 3. That's the same thing as adding 35, 45, 35, 45, right? So I'm still adding up multiple numbers. I'm still going with the sig fig rules, right? So this was just a shortcut. To get to my 162.20 grams per mole. If we tried another one, because there will be one on the test, what about carbon dioxide? CO2. What would the molar mass of carbon dioxide be? Well, carbon is 12.01, and I have two oxygens at 16.00 each. 16.00 each. Now, in your head, you hopefully are at a point where you're like, that's 32. 32 and 12, 44.01. 44.01 grams per mole. So we're adding up all the parts, the mass of all the different parts. And this would be the molar mass of carbon dioxide. 2/16 because there's two oxygens. 2/16 because there's two oxygens. Hope this helps you.